Hello everyone, it's Benny, and today we're going to make our first C++ program. Now, in order to actually make a C++ program, there's two things you need. First off, you need a text editor. Any kind, doesn't matter. Some are better than others, some offer like code-specific features, like maybe they'll guess what you're about to write for you so you don't have to type this really long line, or maybe they scan for your file and see if there's errors in it. I don't know, some of them do more fancy things. But really, if you can type text into it and save it, that's all you need. So there you go, you need a text editor. The next thing you need is something that's technically called a toolchain, but a lot of people just bundle the whole thing under the term compiler. And what that does is it does two things. First off, it takes your wonderful text file full of C++ code and translates it, I guess is a good word. Yeah, it translates all that into actual binary code that your processor can execute, whatever processor that might happen to be. So, there you go. That's all the compiler does. And the second thing it does is something called linking. Essentially, you don't have to write all your big giant C++ program in one text file. You can have multiple text files, and in fact, they don't even all have to be C++ files. You can have files in multiple different programming languages if you want. And that's why there's linking. Linking will say, for example, if I'm writing one text file and want to use some code in a different text file, then the linker will go through and figure out, oh hey, the code we're executing is actually this code over here. And I'll just link all these files together, figure out what code's executing what, and then just sort of put it all together into the big, giant final program. And there you go. Now, here's the good news. You can download all of this, so a text editor, which is really good at editing C++ code, and one of the better compilers / toolchains, whatever term you prefer, out there, all in one nice bundled little package, if you're on Windows at least. Because Microsoft has a product called Microsoft Visual Studio Express, and I'm using 2012 version, but you can use earlier versions if you prefer. And it has all this in one nice, neat little package. You just double-click it, install it, and there it is. So yeah, it has the text editor, so you can edit C++ code with a whole bunch of fancy features to make it easy. It has a compiler and linker, which is incredibly easy to use. You can literally just hit a button and it'll compile all your code for you. And yeah, it's a really nice tool to develop code with. And tools that are like that, which have everything bundled together, just so you know, the technical jargon for that is Integrated Development Environment, or IDE for short, just so you know. Now, how do you actually get this? Well, what you do is you go to Google, you type in Microsoft Visual Studio Express 2012. It should take you to Microsoft's site. They should have a download link, which has some installer. Double-click it, install it, there you go. Now, if you're not on Windows, I'm not going to recommend, well, I'll recommend something, but I won't walk you through like that, because, you know, downloading and installing stuff, I'm going to assume you're capable of doing that. Yeah. If you're on Mac, Xcode tends to work really well. A lot of people are happy with it, but if you're on Linux, then really there's so many tools out there that it's up to your preference. CodeBlocks is pretty good. Eclipse CDT is pretty good. Those would definitely be my top two recommendations for Linux users, or for people who just want to use something that works on all platforms. Those are pretty good. But really, just search around, find what works for you. You know, it doesn't matter. I'm going to be using this, and yeah. So, with all that out of the way, now that you have gone through the installation process, gotten your favorite IDE set up, got everything working, let's go ahead and write our very first C++ program. So, first off, just because I know someone is going to ask me this, how do you get your Visual Studio to look all dark and evil like this? Well, what you do, go to Tools, Options, under Environment, just change this color theme to dark instead of light. There you go. It's that easy. That makes all those people happy. Sorry I had to do that. Now, to create the actual code, first thing you want to do is you want to click New Project, or go to File, New Project, either one, whatever way you prefer, and you'll get this nice, big, fancy menu for how to create a project. And you can create several different sort of template projects, which sort of lay something out for you. Like, if you select Win32 project, then Microsoft gives you this nice thing which has this Microsoft Windows window set up for you, so you can do stuff there. But I'm just going to keep things really super basic and just use a console application. So, and actually, there's one thing that you want to take into account, and that is you want to know where this thing's being saved. So I'm going to go and save it under Adventure, because I have this giant Adventure folder. I'm going to go to Workspaces, and I'm going to create a folder. I'll just call it, I don't know, whoops, C Tutorial Workspace. And you can call it whatever, it doesn't matter. So there you go, and select folder. So that's where I'm going to save it. You can use a default location if you want, but it's just kind of important to know where Microsoft is saving all these things for you. Or if you're not using Visual Studio, whatever the idea of your choice is. Again, not going to go over that anymore. But yeah, so console application, I'm going to call it Hello World. And you can already guess what this application is going to do. Yeah. So click OK, and it gives you this nice wizard to create it. I'm going to click Next. Now, it does check a few things by default that you probably don't want. You probably don't want security development lifecycle checks or precompiled headers, and you probably want to just start off an empty project, just to keep things simple. Okay, so once you've actually created the project, it should give you a project in your Solution Explorer. Yours probably says Hello World instead of Hello, but yeah. So, doesn't matter though. I'm going to right-click on source files, because this is where all your source code goes. Gives you some folders. I'll go over that later, but for now, we're going to go in source files, add new item, and it gives you a nice menu of all 2 files you can create for C++. I just want regular C++ file, so it's going to be main.cpp. You can call whatever, but I'm going to call mine main. And it's generally a good idea, because, well, I'll go over that later, but for now, it's generally a good idea to have your first main file called main. So, here's where I actually start coding. What code actually works, and I'm actually going to just take this and make it smaller, so you have a little bit... no. Oh dear, this isn't... not what I intended, but hey. Yeah. Just to give you a little bit more room to see the non-existent test file. Yeah. So, as for what code you have here, first off, I'm just going to write some code. I'm not going to explain it. I'm not going to tell you what it does as we're writing it. At least I'm going to tell you what it does afterwards and how everything's working, why it does what it does. But to start off with, just copy exactly what I have here. Make sure every capitalization is correct. Make sure every symbol is correct, every character, everything. If it is not an exact replica of this, there's a pretty good chance it's not going to run. So, first off, type pound, number sign, in the hashtag, whatever you want to call it. The tic-tac-toe looking thing. Include. Not include. Nope. There. It should change color slightly if you type it correctly and you're in Visual Studio. So now, include IO stream. It should come up, so there you go. Make sure it's in between the angle thingies. So there you go. Now, int space main, open bracket, close bracket, and type std : cout space double fluff thingy. I'm so good at these names, don't worry. Open quotation, close quotation, hello world. And then just do 2 more of the quote thingies. Wait, std : endo. And then a semicolon. The semicolon's actually important. Like I said, every single part of this is important. If you don't have exactly this, chances are it's not going to run. So now, you have the C++ program. What it actually is at this point really isn't that important. The important thing is now we have valid C++ code, and the computer can't execute C++ code by default. It has to actually take all the code and turn it into binary instructions. So guess what we're going to do? We're going to compile it. As I said, Visual Studio makes this incredibly easy. Just type build solution. It will compile everything. Or you can just hit compile if you want, but build solution builds everything, so why not? You can also hit F7 if you're a hotkey person like me. So there you go, and you'll get some output here. And it should say succeeded if everything works. If not, you probably screwed up somewhere. That's alright. So now that's actually built, you can run it. You can actually go in the folder and execute it manually if you want, but I'm not going to do that. I'm going to go to, where is it? Debug. I don't know why it's under debug, but it is in here. And just click start without debugging. That manually executes the program. It does name it a little bit weird, but hey, there you go. And you notice, brings up console window, says hello world. So there you go, hello world in C++. Now that you actually have something working, you've actually compiled it, and you've run the executable file that's generated. Actually, just to prove that to you, if I go to Adventure, to Workspaces, wherever it's saved, under my Hello project, if you look, it actually has generated an executable file right here, and I could double-click this and run it. And it would actually just go away immediately, since, you know, I'm running from command line, but yeah, there you go. It's actually generated an executable file, which does this, it displays hello world. So yeah, there you go. Now, what exactly does this do? And, well, you know what it does, but why does it do what it does? And why is it done that way? So, I'm going to start going through what exactly this code is, what it does, and yeah, exactly that. Okay, first thing I want to bring up is that C++ has a certain design philosophy behind it. And I think if I had to summarize that in a single sentence, the best it would be is, you don't pay for what you don't use. So C++ is really designed to only have exactly what you need and nothing more. So you may know in languages like Python you can just do print hello world, but C++ doesn't quite do that. And the reason why is because what if your program doesn't involve any printing at all? Then you've just loaded a bunch of data on how to print text out and you're not using it. So again, you don't pay for what you don't use. I want to bring that up because that sort of ties into what this very first line of code does. Like I said, not every application needs to display something to a console window, because then you'd be paying for something you weren't using. And that's why the very first line of code is number include IOStream. What IOStream is a software library. I'm going to talk about that a little bit later. But basically, it's just a whole bunch of C++ code which does various things. In this case, the software library is IOStream, which has has code for printing out text. And if I do number include, that includes it into the program. So yeah, that means, hey, we are going to be printing out text, so do load all that data. So again, just following that design philosophy, you don't pay for what you don't use. So now, this int main stuff, what's all that about? Well, as I said a little bit earlier, when you're writing C++, you can have a lot of different files, which aren't even necessarily in the same programming language. So, if you get all these files, how does it know where you want it to start executing? Where's line of code? Where's line 1? Where does it start? Exactly. That's why you have this thing called the main method. And all that is a place for the program to start executing. So, wherever you type int main, like this, C++ knows, oh hey, this is where you want the code to start executing. This is where I start. This is where, in this giant sea of 10 million lines of code, this is line 1, quote unquote. This is where everything starts. And you do this by typing int main. And now, you do have these two curly braces. And that has to do with methods, which is something I don't want to go too deeply into in this video. But essentially, what this is saying is that all the code in between here is part of the main method. And anything that's not executed from here doesn't get executed at all. So there you go. Just so you know. So this is where essentially all your program has to either be executed, or more realistically, this is where you have to call all the parts of your program that you want to execute. So yeah. So essentially, this is saying this is all the code in the program, because this is all the code that's between these two brackets. This is all the code that physically gets executed. Well, I say physically, but you know what I mean. So now we get to this sort of weird looking line of code, which is saying std : cout. Looks like some sort of ancient cryptographic hieroglyphs or something, doesn't it? Yeah, it's a little bit weird. But if you mouse over std, you'll notice it says namespace. And namespaces, I guess I can talk a little bit about them. Again, sort of out of the scope of this video. But essentially, this code, cout, it doesn't just exist, it's in this thing called a namespace. And when you have a namespace, what that essentially does is just says all this code belongs to this general area. So for example, I want to have all this code which only deals with drawing squares on the screen. And that's probably not the greatest example of where you'd want to use a namespace, but hey, it works. So yeah, I have all this code, all these different pieces of code which are associated with that. And how do I determine that from other pieces of code? Like, let's say I have a piece of code in drawing all these squares that says, let's say I have one of the actions I have, one of the pieces of code is called draw pixel. It draws one of the pixels onto the screen. What if I have something else that draws triangles, and that also has a draw pixel method, which does something completely different? How do I distinguish between them? Well, that's sort of why namespaces exist, to prevent conflicts like that, to say, hey, this is a draw pixel, which is based on square, so you do square, : draw pixel, and then triangle : draw pixel, if you made namespaces for them. That's, again, not the most perfect example in the world, but yeah, there you go. So that's sort of what a namespace is. Again, not sort of out of the scope of this video, but you have this namespace called std, short for standard. These are all the functions which sort of are quote-unquote standard. You can count on the computer being able to do them in some form or another. So, in order to distinguish the standard cout function from any other function you want to call cout, you do standard : cout. There you go. And cout does is it displays text of some sort. Now cout's actually a little bit weird because what you do is you do I guess that's technically the shift. Make sure I get this right because I always get these two mixed up. That's shift left, technically. I always get those backwards for some reason. But yeah, that's just technically the shift left operator, but here what it does is it doesn't do any shifting, it just displays. It says, hey, this is what you want to display, hello world. It just keeps on adding things onto this. So if I want to say hello world and then say hello world, this is an additional message, and then add that back on, I could do that. And if I rebuild the program, I hit F7, the hotkey, and run it. I'm also going to use the hotkey, which is Control F5. See, there you go. It just sort of adds things on to what you want to display. So this is always display something. This is just saying, okay, now I'm going to display, starting with nothing, I'm going to add on hello world. Then I'm going to add on space. This is additional message spelled incorrectly. Actually, let's leave it spelled incorrectly, because why not? And then add on this thing called std end L. What's that? Well, how do you represent enter in a text message? Well, exactly. That's what this thing's for. This is part of the standard namespace. All this does is when you add this onto a text message, it says, oh hey, this means they want enter. They want the line to end. So yeah. So that means if I do something else, so let's say std cout, this is another line, and semicolon, because every single line has to end with semicolon. Almost forgot about that. Every line of code you write ends with a semicolon. That's one of the C++ conventions. Why it's there? I'll actually talk about that a little bit later, but that's sort of out of the scope of this video. Right now, I just want to sort of give you a taste of what a C++ program does. And by the way, I'm not expecting you to absorb everything that I'm going over right here, so don't feel like you have to understand everything perfectly. I'm just sort of trying to give you the feel, trying to get you sort of the mentality of, hey, this is sort of the thought process behind C++. Now, if I run again, it automatically builds if you just hit run. Notice it's doing it on another line. So I hit enter, essentially. I know since I didn't do it there, the press any key to continue is just sort of pushed right at the end of it. So yeah, that's what the endl thing does. So there you go. But there's one more thing I want to talk about. We're using std a fair bit here. What if I just say, the only cout I'm going to have is the standard cout. I don't want to have my own cout function. I don't need to distinguish between them. Well, there's another way of writing this program where it will automatically use the namespace. And I won't have to have std like that. All you have to do is you have to type above here using namespace std. Guess what that does? Whenever you type some function like cout or something like endl, it won't just search, hey, this is your source file, you don't have anything called cout, you're full of crap, this code doesn't exist. It doesn't do that. It says, hey, so it's not in here. It's saying it wants to use things from the std, so let's also check in std, the standard namespace. And it will find them there. So there you go. That's sort of the way C++ code works. There's only really one more thing I want to talk about, and I want to talk a little bit more about this include statement here. Because it looks a little bit different from the rest of the program. It has a sort of number sign, pound, tic-tac-toe grid, hashtag, whatever you want to call it, in front of the include statement. That actually means something very special. That means this is executed by something called the preprocessor, but that's not really the important thing. The important thing is this is done before it even tries compiling your code. It will do whatever this is supposed to do before everything. And not everything can you just put a hashtag in front of it and say, oh, I just want to run my whole program in front of, before it even compiles. So I'm just going to put pound in front of everything. Yeah, as you can see, it doesn't quite work like that. So, oh, yeah. Yeah, you can't do that. But there are a few things which work like that. And so they're all separate, but that's sort of the convention, the way you know this is done before it even tries compiling it. So the way this actually works is it takes the contents of this IOStream file of code and literally just deletes this line and copies and pastes it in place of it. So, yeah. I think it's fair to share that with you, because, it's not like magic. It doesn't, unlike it says, oh yeah, it wants to use this, so I'm going to build it, and then it's just going to link magically. Although there is linking involved, it literally just copies and pastes the entire piece of code into your piece of code. So, yeah. So you can do some interesting things with that. And that can also bite you if you use it incorrectly. So yeah, this is pretty much all I wanted to talk about in this particular video. Again, not expecting you to really understand everything. I just want you to get a feel of how does C++ code work. How does this giant cryptic message even remotely resemble something that's even remotely meaningful? That's the point of this video. That's what I'm trying to get across. I'm not expecting you to remember, well, maybe you'll remember something, but I don't expect you to just memorize, just sit down, okay, this is exactly what he did, now I can make this giant printing device, You know what I'm saying? Yeah. And if there's anything I want you to take out of it, it's the C++ quote-unquote language philosophy. You don't pay for what you don't use. There's a reason C++ is designed the way it is. There's a reason some things seem a little bit backwards. And if you really think about it, you don't pay for what you don't use is really it's sort of like a unifying factor. It makes a whole bunch of things in C++ that are a little bit weird all make sense, because it's designed with that concept in mind. So anyways, thank you. Hope you enjoyed. And in the next video, we're going to get into actually talking about, I guess you could say, more of the actual code. Not just, this is what C++ sort of feels like. This is, yeah, more like we're actually going to sit down and we're going to create real C++ code. Like, well, not this isn't C++. You know what I mean. Yeah, in the next video, we're going to do stuff. See you next time.